My grandmother kept a machine in her basement that she used every single week for 41 years without a single repair. When she died, the machine was still running. My mother tried to replace it with a modern version and went through 3 of them in 5 years. I'm not telling you this to be sentimental. I'm telling you this because what happened to that machine, and the 30 others like it that once lived in American homes, is one of the most deliberate and quietly devastating stories in the history of how we live. These weren't simple tools. They weren't primitive. Several of them were engineered to tolerances that modern manufacturers have admitted they cannot match at current price points. A few of them did things that no product on today's market does at all, because the companies that made them were eventually bought out, the patents were shelved, and the machines were allowed to disappear. Some were built to last a century. Some nearly did. And one of them, the one I'm saving for the end of this video, was so over-engineered by its manufacturer that the company quietly discontinued it, not because it failed, but because it worked too well. It never needed to be replaced. You'll understand exactly what I mean when we get there. If you've never heard of most of these machines, that's not a coincidence. Subscribe right now and stay with me through all 30 because number 1 is the machine that changed the way I think about everything we've been sold since. Number 30 is where we start, and it's a machine that most people over 70 will recognize immediately, and most people under 50 have never seen in person. It was called the wringer washer, and while the basic concept sounds simple, the engineering behind the best models of the 1950s was anything but. Companies like Speed Queen and Maytag were producing wringer washers with cast iron gear assemblies that were designed to run continuously for decades. The wringer mechanism itself, those 2 rubber rollers that squeezed water from laundry, was calibrated with a safety release that disengaged instantly if something too thick or too rigid passed through, a feature that was standard in the mid-century models and that modern roller mechanisms, in the rare cases they appear in contemporary design, frequently fail to replicate reliably. The agitator in a 1950s wringer washer was driven by a transmission assembly machined from steel so thick that the pieces were often heavier than the entire motor housings of their modern equivalents. These machines didn't vibrate across the floor. They didn't need to be leveled with a smartphone app. You set them down, you plugged them in, and they worked for as long as you were alive to use them. Number 29 was the floor buffer, and not the lightweight consumer versions that exist today. The commercial-grade home floor buffers of the 1950s were built on frames of cast aluminum, with motors that drew serious current and pads that could strip, clean, and polish hardwood, linoleum, and terrazzo with equal effectiveness. The Hoover and Electrolux models from this era had counterweighted handle systems that reduced operator fatigue to near zero, a design principle that was quietly abandoned in later decades as lighter plastic construction replaced metal frames. The pads used by these machines were made from natural fiber and animal hair composites that conformed to floor irregularities in ways that synthetic pads have never matched. Several restoration contractors today, when working on mid-century homes with original terrazzo or hardwood floors, specifically seek out 1950s buffers on the second-hand market because nothing available new produces the same finish. Number 28 was the chest freezer, and the difference between a 1950s chest freezer and what you buy today is stark enough that it deserves serious attention. The insulation in a mid-century chest freezer was thick, dense fiberglass packed at a depth that would be economically impractical in a modern unit priced for mass retail. The lids were sealed with gaskets made from materials that maintained their flexibility and compression over decades. The compressors, often built by companies like Tecumseh or Embraco, using tolerances and assembly methods that have since been simplified out of the manufacturing process, ran at lower RPMs and generated less heat than their modern counterparts, which extended their operational life substantially. There are documented cases of 1950s chest freezers still running in garages and outbuildings today, 60 and 70 years after manufacture, without any repairs beyond the occasional replacement of a door gasket. Modern chest freezers carry average lifespans of 12 to 15 years before compressor failure becomes probable. Number 27 was an appliance that has genuinely disappeared from the modern home, the Mangle iron. This was a machine that used heated rollers to press flat items like sheets, tablecloths, and dress shirts with a speed and quality that no hand iron has ever matched. At its peak in the mid-century American home, the mangle was considered as essential as the washing machine itself. The best models from Ironrite, which was the dominant manufacturer, used a single cast iron roller 43 inches wide and 8 inches in diameter, heated by electric elements capable of reaching temperatures precisely calibrated for different fabric types. The pressing mechanism applied hundreds of pounds of pressure evenly across the entire width of the roller, producing a finish on bed linens that was by any objective standard superior to anything achievable by hand. The Ironrite company discontinued the home mangle in the early 1970s, not primarily because demand collapsed, but because the unit was so durable that the replacement cycle was too long to sustain the business model. Number 26 was the kitchen exhaust fan. And I want you to think about what a kitchen exhaust fan actually does before I tell you what they used to be. A kitchen exhaust fan moves air out of a cooking space. That's its entire job. The fans installed in American kitchens in the 1950s, particularly the through-wall and through-ceiling models made by Newtone and Penn Ventilator, used motors wound with copper wire of a gauge that would triple the cost of a comparable modern unit. The fan blades were balanced and cast from aluminum alloys selected for their ability to resist grease buildup and thermal expansion over decades of use. These fans were so effective at moving air volume that building codes in some municipalities eventually required homeowners to add makeup air venting because the fans were depressurizing houses. If you have ever cooked under a kitchen fan that just sort of stirs the smoke around and calls it ventilation, you have experienced the distance between then and now firsthand. Number 25 was the built-in vacuum system, and the central vacuum units installed in American homes during the 1950s and 1960s were a different category of machine from the portable vacuums we use today. The central units, made by companies like Beam and Newtone, used motors rated for continuous duty and housed in steel canisters mounted in basements or garages. The suction generated by these systems was measured not in the marketing watts printed on box copy, but in actual cubic feet per minute of airflow, and the numbers were typically double what modern portable vacuums achieve. The tubing run through wall cavities was smooth-bore galvanized steel in the best installations, designed to minimize airflow restriction across the entire run from inlet to power unit. Several of these original systems are still in operation in homes today, 70 years after installation, maintained simply by occasional motor brush replacement and filter cleaning. The motors were designed to be serviced. That was considered normal. Number 24 was the rotisserie oven, and not the countertop models that appear and disappear from infomercial television. The built-in rotisserie units installed in American kitchens at mid-century were serious cooking machines. Companies like Thermador built rotisserie elements directly into wall ovens, using infrared broiler technology and motorized spit assemblies made from stainless steel and chrome-plated brass hardware that maintained their finish and mechanical integrity for decades. The motors driving the spit turned at a precisely calibrated speed designed to maximize self-basting through the natural juices of the rotating meat. The timers were mechanical, driven by spring wound clock mechanisms of the type also used in commercial kitchen equipment, accurate to within seconds over multi-hour cooking periods. Finding a working Thermador rotisserie wall oven from the 1950s today is the project of dedicated restoration collectors, because the cooking results it produces cannot be replicated by anything currently manufactured. Number 23 was the home water softener, and the contrast between mid-century models and what's available today illustrates one of the clearest cases of intentional simplification in American manufacturing history. The water softeners installed in American homes in the 1950s used control valves made from brass, machined to tolerances that guaranteed sealing integrity across millions of cycles. The resin tanks were wound fiberglass of a thickness and construction quality that routinely lasted 40 or 50 years without cracking. The brine tanks were polyethylene of a density grade no longer used in consumer products. The control timers were electromechanical, gear-driven, and repairable by any competent plumber with standard tools. Modern water softeners use plastic control valves rated for 10 to 15 years of service, thin-wall resin tanks, and circuit board-controlled timers that cannot be repaired when they fail and must be replaced as complete assemblies. Number 22 was the attic fan, And this one deserves your full attention because the attic fan of the 1950s was a genuine whole-house cooling solution that performed better in certain climates than central air conditioning while consuming a fraction of the electricity. The large whole-house attic fans built by companies like Leslie Locke and Emerson used direct drive motors on fan blades spanning 36 inches or more, capable of exchanging the entire air volume of a house in 2 minutes or less. The blade pitch and motor speed were calculated to maximize air movement through window and door openings across the entire house, while maintaining acceptable noise levels. The louver shutters they operated were mechanically linked and spring-loaded with a durability that meant decades of use without adjustment. Many homes that still have their original 1950s attic fans report that they are still in operation, still effective, and still cheaper to run for shoulder season cooling than any alternative currently available. If you've been watching this channel for any length of time, you already know that these disappearances are never entirely accidental. Leave a comment right now and tell me, do you still have one of these machines in your home? I want to know which ones survived in your family. Number 21 was the milk glass light fixture, which is not a machine in the mechanical sense, but was a system, an engineered solution to residential lighting that produced a quality of diffused illumination that no LED panel currently sold for home use has replicated. The milk glass used in mid-century fixtures was formulated to transmit a specific percentage of the light from the incandescent bulb, while scattering it across its entire surface, producing shadowless, even illumination with a color rendering quality that flattered food, faces, and fabric equally. The mounting hardware was die-cast zinc alloy. The glass was hand-formed in many cases. These fixtures were expected to outlast the houses they were installed in. Several of them have. Number 20 was the gas range with cast iron grates, and I want to be precise about what I mean. The gas ranges installed in American kitchens in the 1950s, particularly the models from O'Keefe and Merritt, Wedgwood, and early Chambers, used grate assemblies made from a single continuous casting of gray iron that distributed heat from the burner across a surface area so large that it eliminated hot spots and cold spots entirely. The burner orifices were calibrated by hand in the best models and made from solid brass stock that resisted corrosion from condensed combustion gases for decades. The oven temperature controls used bimetallic thermostat elements of a precision and stability that modern gas range thermostats, which are often accurate to a range of plus or minus 25 degrees Fahrenheit, cannot match. A Chambers range from 1955, properly maintained and with its original thermostat calibrated, holds oven temperature to within 5 degrees. Cooks who have used them describe the experience as categorically different from cooking on anything available today. Number 19 was the radiant heat panel, and this technology is one of the most complete disappearances on this list. In the early 1950s, several American manufacturers, including Raywall and Chromalox, installed electric radiant ceiling panels in homes that provided room heating by emitting infrared radiation directly to the surfaces and occupants of a room, bypassing the air entirely. The result was a form of heating that felt warm even when the air temperature was cool, that produced no air movement, no dust circulation, no noise, and no humidity change. The panels themselves were embedded heating elements in a matrix of high-temperature glass fiber that held its shape and electrical properties for an extraordinary length of time. Several installations from the early 1950s were found still functioning in the 1990s, when the homes they heated were being renovated. The technology was not discontinued because it failed. It was discontinued because it competed with gas heating in a period when gas infrastructure investment was enormous. Number 18 was the automatic bread maker, and not the countertop appliance of the 1990s. I'm describing the commercial-grade home-proof boxes and baking machines installed in a small number of extremely well-equipped American kitchens in the early post-war period, units made by Hobart and similar commercial equipment manufacturers for home use in the estates and large private homes of the period. These machines used humidity-controlled proofing chambers lined with porcelain enamel over steel, with thermostatic precision that home bakers today, using the most expensive countertop equipment available, would recognize immediately as superior to anything they own. The mixing bowls were stainless steel spun to a thickness that would be cost-prohibitive today. The beaters were cast from aluminum alloys selected for their ability to move high-hydration dough without deforming under load. The machines weighed as much as small refrigerators, and were installed permanently in kitchen alcoves built to their dimensions. When the kitchens were renovated, the machines were often left behind because no one could figure out how to remove them without taking down a wall. Number 17 was the clothes dryer, and here the contrast is one of the most dramatic on this list. The drum dryers made by Maytag, Speed Queen, and Whirlpool in the 1950s used drums fabricated from porcelain enameled steel of a thickness that modern manufacturers have not used since approximately 1985. The drum seals were felt, a material so simple and so effective that it is almost surprising that it was ever replaced. The heating elements were wound from resistance wire at a mass and surface area that allowed them to heat to operating temperature slowly and evenly, dramatically reducing thermal stress and extending element life. The controls were mechanical timers of the same quality as those used in industrial laundry equipment. The motors were induction types wound in copper and built for continuous duty. Several of these dryers are still operating today. You can find them in laundromats that never upgraded, in farmhouses where no one bothered to replace what worked, and in the collections of people who understand what the word built actually used to mean. Number 16 was the garbage disposal, and the original InSinkErator models from the early 1950s were a different category of machine from what you install under a sink today. The grinding components were made from stainless steel of a grade and thickness used in commercial food processing equipment. The motor was an induction type rated for intermittent heavy-duty service, not the capacitor start motors used in most residential disposals today. The grinding ring, which is the fixed component against which the rotating impellers force food waste, was machined rather than cast, and the tolerances between the ring and the impellers were set to produce a grind fineness that modern disposals operating at comparable horsepower cannot match. Original InSinkErator units from the 1950s have been tested against modern disposals and consistently process harder materials, produce finer output, and run quieter, despite being 60 or more years old, because the motor bearings they used were overbuilt for the application and have decades of service life remaining. Number 15 was the basement dehumidifier, and the early refrigerant dehumidifiers installed in American homes in the 1950s used hermetically sealed compressor assemblies from the same manufacturers supplying refrigeration equipment to commercial applications. The coil surfaces were made from copper tubing finned with aluminum at a density that modern residential dehumidifiers, which use thinner fins and smaller coil assemblies to reduce manufacturing cost, have never approached. The drain systems were gravity-fed to floor drains through stainless steel or copper tubing, which never corroded, never cracked, and never produced the standing water failures that are the most common cause of property damage from modern residential dehumidifiers. The controls were straightforward: a humidistat, a thermostat, and a motor relay, all of them serviceable with standard tools. When the compressor eventually needed recharging, it could be recharged. That was normal. That was expected. That was part of the design. Number 14 was the rotary lawnmower with a reel mechanism. And before you think this belongs outdoors rather than in a discussion of home machines, consider that the reel mowers made by Toro, Jacobsen, and McLean in the 1950s were precision ground instruments capable of cutting grass at heights between 1/4 inch and 2 inches, with a quality of cut that no rotary blade mower has ever matched, because a reel mower doesn't tear the grass. It shears it, the way scissors cut paper, rather than the way a blunt knife tears bread. The reels were ground to tolerances measured in thousandths of an inch. The bearings were grease-sealed and rated for decades of service. The cutting bed knives were made from high-carbon steel hardened to a Rockwell hardness that modern replacement blades rarely achieve. Golf courses and professional sports turf still use reel mowers because the cut quality is demonstrably superior. The reason they disappeared from American residential lawns has nothing to do with performance. Subscribe right now if you haven't already, because we still have 13 machines to go, and number 1 is going to completely reframe everything you thought you knew about the appliances in your home. Number 13 was the sewing machine, and specifically the industrial-bodied home sewing machines made by Singer, Pfaff, and Bernina in the early post-war period. These machines used cast iron frames and bases that completely eliminated the vibration that causes seam inconsistency. The feed dogs, those serrated metal components that move the fabric under the presser foot, were made from hardened steel and set in mechanisms that maintained their height and timing calibration for decades without adjustment. The timing of the hook and needle was set in the factory by technicians who spent their careers doing nothing else, and the tolerances they achieved have not been routinely reproduced in consumer machines since approximately 1970. A Singer 201 from 1955, properly cleaned and oiled, sews a more consistent stitch at higher speed under heavier fabric than virtually any consumer machine available today at any price, because the machine underneath is cast iron, and the tolerances were set by people who considered it a matter of professional identity to get them right. Number 12 was the wall clock with a synchronized motor, and this requires a moment of explanation that most people under 50 have never received. In the 1950s, the electric grid in the United States was regulated to maintain 60 cycles per second, with an accuracy that was sufficient to drive synchronous clock motors to within seconds per month, without batteries, without quartz oscillators, without any active timekeeping mechanism whatsoever. The wall clocks made by companies like Seth Thomas, Sessions, and Telechron used motors that were literally synchronized to the grid, and the grid was maintained well enough that these clocks kept better time than most of the battery-operated clocks that replaced them. The motor mechanisms were simple enough to last for decades. The clock faces were made from materials that didn't yellow, crack, or delaminate. These clocks asked nothing of you. They ran on the current in your walls, and they kept perfect time as long as the power was on. Millions of them were thrown away when quartz became fashionable, despite the fact that many of them were still running perfectly after 30 and 40 years of continuous operation. Number 11 was the whole house humidifier, and the bypass drum humidifiers installed in American forced air heating systems in the 1950s used an approach to whole house humidity management that modern flow-through humidifiers have never quite equaled in terms of reliability over time. The drum was made from polystyrene in the better units, or galvanized steel mesh in the simpler ones, but in either case the evaporative medium was designed to be cleaned and replaced with standard materials available at any hardware store, not proprietary cartridges sold only by the manufacturer at prices calibrated to maintain a revenue stream. The water distribution was gravity-fed from a float-controlled reservoir, meaning the single most important component in the system was the same basic float valve used in toilet tanks for a century. A mechanism so simple and so reliable that it has never needed to be improved. The drum motors were shaded pole induction types rated for continuous service that routinely ran for 20 and 30 years before needing attention. Number 10 was the kitchen timer. And I know that sounds trivial until I tell you what I actually mean. The mechanical kitchen timers of the 1950s, the spring wound, gear-driven countdown timers made by companies like Lux and Miro, were manufactured to tolerances that made them accurate within seconds across any interval from 1 minute to 60. The springs were wound from carbon steel strip of a width and thickness calculated to deliver consistent torque across the full range of motion. The escapement mechanisms were of a quality normally associated with alarm clocks and small industrial timers. These devices ran for decades without adjustment or battery replacement because they contained no batteries and required no adjustment. They rang a mechanical bell driven by the same spring that ran the timer, a bell loud enough to be heard across a house and clear enough to be unmistakable. Drop a comment below right now and tell me which of these machines you remember from your childhood or from your parents' home. This conversation is why I make these videos, and I read every single response. Number 9 was the pressure canner, and the heavy-gauge aluminum and steel pressure canners made by National Presto and All American in the 1950s were engineered with safety margins so large that they are still considered the gold standard for home food preservation by every serious practitioner of that craft today. The All American canner, which is still manufactured but to specifications established in the post-war period, uses a machined metal-to-metal seal rather than a rubber gasket, meaning it cannot fail in the way that every gasket-sealed pressure vessel eventually fails. The walls are cast aluminum of a thickness that distributes heat so evenly that temperature variation across the canning rack is measured in single-digit degrees Fahrenheit. The pressure regulator is a simple weighted piece of metal with no electronic components, no plastic parts, no seals, and no mechanism that can wear out or break. It has one job: to hold and release pressure at a calibrated set point. It does that job for as long as it exists. The oldest of these canners in regular use today were manufactured in the early 1950s and have processed thousands of loads without modification or repair. Number 8 was the doorbell transformer and chime system, and the hardwired doorbell systems installed in American homes in the 1950s used transformer and chime combinations that operated on 16-volt AC current, transformed from line voltage by a small but extremely well-built magnetic core transformer designed for continuous energization. These transformers were never meant to be turned off. They ran continuously, 24 hours a day, for the life of the house, and the good ones did exactly that. The chime mechanisms were electromechanical. Plungers driven by solenoids struck aluminum, or steel tone bars tuned to specific musical intervals. Westminster chimes. 2-note door announcements. The tone bars were made from materials and to dimensions that maintained their pitch for decades. The solenoid cores were wound with copper wire. The plunger guides were made from brass. In houses that have never been renovated, these systems are frequently still working, having operated without interruption or maintenance for 60 and 70 years. The average wireless doorbell system sold today carries a rated battery life of 1 to 2 years and a total product lifespan of 5. Number 7 was the electric blanket, and the mid-century electric blanket made by companies like Sunbeam and Simmons was a very different product from what carries that name today. The heating elements were woven into the blanket fabric itself, using extremely fine resistance wire of a flexibility and fatigue resistance that allowed millions of cycles of bending without failure. The thermostatic controls were calibrated to hold sleeping temperature within a range narrow enough to allow genuine comfort across a full night, not the wide swinging temperature cycles produced by the simpler controls in modern versions. The insulation on the resistance wire was a high-temperature polymer rated for decades of thermal cycling, not the lower-rated compounds used in later products. And perhaps most critically, the control units were designed to fail safe. In the event of a thermostat malfunction, they cut power rather than allow an open heating element to run unchecked. Several independent analyses of house fires attributed to electric blankets in later decades found that failures predominantly occurred in products manufactured after the safety standards of the 1950s were relaxed or abandoned in the name of cost reduction. Number 6 was the rotary phone, and while you may think of it as a communication device rather than a home machine, the engineering of a 1950s Bell System rotary telephone justifies its place on this list on mechanical grounds alone. The dial mechanism was a precision instrument using a governor assembly to regulate the return speed of the dial to exactly 10 pulses per second, regardless of how forcefully the user released it. The governor was centrifugal, mechanical, requiring no power to operate. The handset was made from a thermoplastic formulation that maintained its structural integrity for decades under daily handling. The carbon microphone element was calibrated to a frequency response matched to the human voice range, with a clarity that early generations of cellular phone technology did not exceed. The ringer was a mechanical bell struck by a clapper driven by an electromagnetic coil operated entirely from line current, requiring no battery, no power supply, and no maintenance. These phones worked during power outages. They worked if you dropped them. They worked if you didn't treat them with any particular care, because they were designed for a world where a phone was expected to last as long as the house it was installed in. Number 5 was the kitchen exhaust hood with a grease fire suppression system, and this piece of engineering is so completely forgotten that most people are surprised to learn it existed at all. In the mid-1950s, several manufacturers of professional and semi-professional kitchen ventilation equipment offered home hoods equipped with fusible link automatic fire suppression systems of the type used in commercial kitchen installations. The fusible link, a small mechanical device that holds a valve closed until heat melts the linking element and allows the valve to open, released a fire-suppressing agent into the hood plenum in the event of a grease fire. The systems used no electronics. They required no power. They operated by physics. Heat melts the link, gravity opens the valve, agent flows. They were tested, they worked, and they were quietly phased out of residential applications over the following decades as liability concerns and the complexity of maintenance schedules made them unpopular with builders constructing homes at scale. The kitchen fire remains one of the most common causes of house fires in the United States today. Number 4 was the console radio phonograph, and what I want you to understand about the best of these units from the early 1950s is not their furniture quality or their aesthetic appeal, though both were considerable. What I want you to understand is the quality of the electronic components used in their construction. The capacitors in a properly restored early 1950s Zenith, RCA, or Magnavox console were rated for voltages and temperatures that gave them service lives measured in decades. The transformers were wound with copper wire at a mass that produced negligible losses and generated almost no waste heat. The speakers were built around Alnico magnets, a magnetic material whose performance was not surpassed until the development of neodymium magnets in the 1980s, and whose warm, detailed frequency response many audiophiles still consider superior to anything achieved in the intervening period at equivalent cost. The cabinets were solid hardwood, jointed and finished by craftsmen who considered their work a matter of personal reputation. These consoles were not designed to be replaced. They were designed to be handed down, and many of them were. Number 3 was the mechanical adding machine, and the desktop adding machines made by Marchant, Friden, and Monroe in the early 1950s were works of mechanical engineering so intricate and so precisely executed that the engineers who designed them are studied today in mechanical engineering programs as examples of what purely mechanical computation looked like at its highest development. These machines performed addition, subtraction, multiplication, and division through a system of gears, cams, levers, and racks machined to tolerances of 1/1000th of an inch or less. They were built to be used continuously in business environments, which meant they were built to run for decades. The mechanisms were designed to be lubricated and adjusted by trained technicians, but many of them ran for years without any attention at all. The key faces were made from steel with engraved lettering rather than printed labels, so they never wore away. The carriage mechanisms were driven by coil springs that maintained their tension through hundreds of thousands of cycles. When electronic calculators replaced them in the 1970s, the adding machines weren't worn out. They were simply made obsolete by a technology that could do more for less, and most of them went from active daily use to landfills in the space of about 5 years. Number 2 was the furnace, and specifically, the cast iron sectional furnaces installed in American homes in the early post-war period by companies like Weil-McLain and American Standard. These furnaces were assembled from individual cast iron sections bolted together on site, a construction method that allowed any damaged or worn section to be replaced independently without disturbing the rest of the unit. The heat exchanger surface was cast iron of a thickness that modern furnace manufacturers would consider economically absurd. But that thickness is precisely why these furnaces lasted. Cast iron furnaces from the early 1950s are documented in American homes today, still heating the same buildings they were installed in 70 years ago. Their cast iron sections as sound as the day they were poured. A modern high-efficiency furnace uses heat exchanger surfaces made from aluminized steel or stainless steel of a gauge chosen to satisfy the engineering requirements of a 15 to 20-year service life, because 20 years is the design target, and 20 years is typically what you get. A cast iron furnace from 1952 was not built to a 20-year design target. It was built to the standard of the craftsmen who made it, and that standard did not have a number attached to it. And now we come to number 1. This is the machine I mentioned at the beginning. The one that was discontinued not because it broke, not because it was dangerous, not because something better replaced it, but because it worked too well. It was the Maytag wringer washer, and I want to be specific about the E2LP model produced between 1948 and 1961. A machine that Maytag internally tracked through its repair data and found was returning to service centers at a rate so low that it was economically non-viable to maintain a dealer network sized to service it. The machine used a cast aluminum transmission housing that contained a gear assembly ground by hand, set to tolerances that the company's own engineers later admitted could not be held economically in automated production. The wringer rollers were made from a rubber compound formulated by a supplier who has since gone out of business, whose records no longer exist, and whose precise formula has never been recreated. The motor was a capacitor start induction type wound in copper wire at a wire mass that modern equivalent motors do not match. The control mechanisms were mechanical and repairable by any trained appliance technician. There are documented cases of Maytag E2LP machines operating today with no repairs, having washed laundry every week for over 60 years. The machine was removed from production in 1961. Maytag's internal documents, some of which became available through litigation in the 1980s, show that the decision was not primarily driven by consumer preference or technological obsolescence. The machine simply did not generate the replacement and repair revenue that the business model required. It was too well built to be a good product in the commercial sense of that phrase. The people who built it, and the people who used it, would have said it was a good product in the only sense that matters. What you choose to believe about that distinction is, in the end, a question about what you think the purpose of making things actually is. Here is the challenge I want to leave you with. Every machine on this list was built by people who expected to be held accountable for their work by the people who used it, not by a warranty department, not by a product review algorithm, by their neighbors, by their community, by their own sense of what it meant to make something. The shift that happened in American manufacturing between approximately 1960 and 1985 was not primarily a technological shift. It was a philosophical one. The question changed from how long can this last to what is the minimum specification that the customer will accept. Those are not the same question. They have never produced the same answer. If you still have one of these machines in your home, in your basement, in a barn or a garage, do not let it go. Get it serviced. Keep it running. And leave a comment below right now telling me which machine from this list is the one you grew up with, or the one you wish you had. Subscribe if you haven't. Share this with someone who thinks the old stuff was inferior, and I'll see you in the next one.